All right. Just checking if my stream is running. Um, I have analytics content live. Well, it's going. It's going on. It's not bad, but yeah. Let's see how this goes today. Okay, so yesterday I started studying stocks, and something happened that took the light, and I couldn't continue my stream. Hopefully, I'm able to complete at least um, an hour of stream. Um, I need to be monitoring my stream today because I'm using a different network. All right. Okay. So yeah, before we continue with tasks, I would like to go over this question I was able to solve yesterday, and you know see how well I will explain it this time around. Right. So let me come here. I think I can do that. This, yeah. All right. So let's go to the question again. So this was the first medium question I was able to solve without looking at the answer. Um, and I'm actually happy about it. So let's go over the question again and read it. So the question is list code 1476. So 1476. Subrectangle queries. Subrectangle queries. Implement the class subrectangle queries, which receives a rows by columns rectangle, right, as a matrix of integers. Um, as a matrix of integers in the constructor and supports two methods. Update subrectangle, which takes the following um, parameters: integer 1, integer row 1. So row 1 is an integer, row 2 is also, sorry, row 1 is an integer, column 1 is an integer, row 2 is an integer, and column 2 is also an integer. Now we are updating a subrectangle, right? So we need to update it with a certain value, which is this new value that was provided here. All right, so the next thing to do is the next thing that this class here has is a get value, right? So this returns the value, the correct value of the coordinates that's been passed to it, right? So it takes the row and column, both are integers, as argument, and returns the current value at that particular point. Update value, update subrectangle, update all value with the new value, right, in the subrectangle whose upper left coordinate is row 1 column 1, and bottom right coordinate is um bottom right coordinate is um row 2 column 2. Now this part here, right, this coordinate here, I will explain what it actually means, right, at least how I understood you know what these values represent. So let's take a look at the example where this class was used. So the first time we instantiate the subrectangle queries. So this is here. We instantiated it with this value here, right? So we passed in this rectangle with all these different subrectangle in it, and the the next time the next operation is get value, right? So we got a value at 0 and 2. So this is a row value, this is a column value, as it was stated in this method here. Okay, and then we also updated the rectangle. So this is a value we provided. So you can see here it says update sub rectangle with this value here. So here's an explanation. We instantiated the sub rectangle queries class, right, with this value here, and then so this is what we had. We had a rectangle like this. So the initial rectangle looks like this. So it's a 4 by 3 rectangle. We have 4 rows, right, and 3 columns. Okay. Now sub rectangle queries dot get value. So we want to get a value at this point here. Row 1, I mean where the row is 0 and the column is 2, right? So where is row 0 in this rectangle here? It's surely at this point here. Row 0 is here, which is every value here, right? But column 2, right, the value of column 2, we have 0, 1 and 2. So column 2 will be somewhere here, which is this 1 here, which is why the answer here is 1. So let me go over to my board again and explain this. I will start here. Okay, so we have um I have this here. I'll just delete this. And one thing that really helped me solve this question was visualizing the rectangle, right? I I needed to see how what the rectangle actually represents. So let me go over this. All right. Okay, so here. All right. Um First of all, a rectangle looks something like this. I'll draw a rectangle here. So let's just draw a rough rectangle here like this. I'll just put this here. And since our rows are more than the columns, right? Anyway, it doesn't really matter, right? A rectangle needs to have one side longer than the other. Although the two sides that are parallel to each other, right, that are facing each other have to be of the same um okay, my stream is lagging. Let me reduce my bit rate already. So I'll bring it back to 1. Change this to 8. Apply and OK. Alright. Okay, so here is what we have. I'll I said two sides that are parallel to each other will need to have the same length, right? But in a rectangle in general, um, the sides that are perpendicular to each other are not of the same length. One side has to be longer than the other one. So let's draw another, side. So I'll assume this is our shorter side. So let's draw another one. We'll go all the way here. Right, this is actually very long. um I'll now go okay I'll now go this way. um Let me just reduce this a little, right, and go from here all the way down. All right, okay, that is good. And then I'll take this one from here all the way here. All right, this is our rectangle, and let's start with the annotation. Now the value passed into our sub rectangle query is a rectangle. Now if we change this, right now the array is in a horizontal form, so I want to put the values in it vertically. So I'll do something like this. I'll have the first value here, the first array here will be 1, 2, 3, right? And then I'll go this way again. I'll have 4, 3, 4, and then another value here will be 3, 2, and 1, right? I don't know why I'm giving so much space. Let me put it here, 4 here, and the other value will be 3, 2, and 1, and another one will be 1, 1, 1 here, 1, 1, 1. I'll just put it like this, 1 like this, like this, and 1 here like this. Okay, so this is our values that represent the rectangle. And if you visualize this, right, when you look at this all the way down, right, you can see, you know, this is actually a rectangle. It takes the shape of a rectangle. It goes all the way, all the way. The entire thing represents a rectangle. And with this rectangle, you can also visualize some other rectangles. So when we go all the way here, right, when we go all the way here, this forms one rectangle. This also forms another rectangle. This also forms another rectangle, and so on, right? These are all rectangles, which are sub rectangles in the main rectangle here, right? I'll just call it R. Okay, so what do we do next? We'll change, we'll go from, you know, this side to properly positioning the points here. So I'll put the points here. We started from 1, we have 2 here, and then we have 1 here. This is the first sub rectangle, right? So what's the next one? The next one will be somewhere here. I'll just put it here like that. I'll put 4, and the next value is 3. The next value would be 4 again. So that's another sub rectangle, or rather a row, right? So we'll have another 3 here. We have 2 here, and we'll have 1. I'll not put it on top. Let me just put it by the side here. We'll have 1 there. And then we'll have, okay, the space is just too much. Well, we'll just manage it like that. We'll have 1, and, you know, 1 here, 1, 1, and 1. Okay, so all of these, right, all of these, you know, represents a form of rectangle. When you draw this line from this side to this place, all the way back, right? Christ. Let me just do it this way. So I'll just draw the line from here to this part here, all the way up, and then back, right? And then back to this part here. I'll just put 2 here. So right, all the way back. That's one rectangle. This is another rectangle. This is another one here. So which is why it is a sub rectangle. So all of this part here represents a rectangle. Now the question is to write a class, right, that takes in an array of arrays, right, a 2D array or a matrix, right, and then create a rectangle out of it. So the first part is to just set you know, an array, or any, just create a value that takes this input, right, from the constructor of this class, which is the init method. And yeah, so you just create it. That's number 1. That's the first part. So which is what I did here. So I just created, you know, a property of this class, which is this rect here. It's just a simple variable that takes the actual rectangle that is being passed to the constructor of this subrectangle class here. So that is all you need to do for this first part. I needed to do for this first part. And then the next one is to update a sub rectangle, right? The update could be any rectangle, right? It could be, you know, a rectangle. I'll just call this R1, right? R2 or R3 or R4 itself, which is the general rectangle itself, right? R4, right? But you want to we want to update a sub rectangle. So a sub rectangle is a rectangle within the main rectangle. So it could be R1, R2, or yeah. So we can have another rectangle going from this part here all the way down instead of the full thing, right? This is also a sub rectangle of the main rectangle. Now, so here's what we need to do. To update a subrectangle, we need some coordinates. But before we get to the coordinate part, I would like to explain what this function does, right? It says update all values with the new value, right? In the subrectangle whose upper left coordinate is row 1, column 1, although this is not going to be the first column or row column, they're just going to provide us a value, right? Row basically is when you look at this, right? Where is this? Sorry. The row, right, is this. This is one row, right? And what are the points on this row? The point of this row is 1, 2, and 1, right? And what do these points represent? These points represent columns, right? So this could be column 1, column 2, and column 3. So it doesn't really matter. But what the question is saying is the updates, the update values, update all values with the new value, right, in the sub rectangle whose upper left coordinate is row 1 column 1, right, and bottom coordinate is row 2 column 2, right? So what this means is upper left coordinates, right? Upper left coordinates, right? Let me get that. Well, let me push it this way. So we want upper left coordinates. Well, that's, to my understanding, right, is really, uh, you know, so let's say this from here all the way here is, the upper side of a particular of this rectangle here, right? From, let me call this R1 here, right? This R1 here is one rectangle. Its upper coordinate will be any value from this left hand side all the way here, spanning across the amount of column that appears in that particular rectangle, right? And then the lower um you know coordinates will be from this side all the way here. So here, let's have it like this. So this will represent one row, this will represent another row, right? This will represent another row, this will represent another row. So currently we have 4 rows in our rectangle, and if we look at this, we should be able to get 4 arrays in our main array. So we have 1 here, we have 2, we have 3, and we have 4. So these arrays here represent the rows in the sub rectangles, and the values within the arrays represent what, the columns. So we have 3 columns. So we start from here, we go all the way down, right, and all the way down. So every sub array has exactly 3 columns. Now, how do we implement this function, right? After seeing that each line here, each array here represents a particular um row, right? Each array in this rectangle or this 3D 2D array that represents our rectangle, after knowing that each array within this array is a row, right, we can begin to guess, right? So if we are given the upper bound, right, the upper coordinate of you know of a particular subrectangle and its lower coordinate, it means we want to update every value starting from a particular row up to a certain row, right? So which is what the update subrectangle um you know method does. So when we are provided a row, and let me use this example here. So I'll say update, where is it, yeah. So update subrectangle like this, right? What it does is basically let me put this here. I'll just paste it here. Okay, that's big enough. uh my god, again. There's no way this thing can be happening every day. Okay, I'm not sure if I can still see my other screens. Um, but yeah. Oh, I'm so sorry. Let me see if I can do it on one single PC. Um, okay. I'll just take this part here. I'm not sure if my screen is still visible. My screen is no longer my screen is no longer visible, but I'll just change it to um oh, they've brought back the lights. It's absolutely um a crazy country we live in. This is how things happen here. Okay. Alright, so they've brought back the lights, and hopefully I can continue with my stream. Let me bring this back here. Alright, uh, let's continue uh, with the stream. I hope my YouTube video doesn't get cut off, because this is really painful. It's painful to watch. Um, okay. All right, so let's continue. Thanks to you too for not cutting off my stream. Um, okay, so we want to update this rectangle, right? We want to implement this update method. So what does this update method really do? So this update method takes a row one. I'll just represent it by R1 and column one, right? And row two and column two with the value we want to update it with, right? This is the value here. Okay, now we also understood that um so what's going on? I'm really suffering. Eesh, this is bad. Like the stream might end anytime soon. Um so the function does this, right? So the function takes the coordinates of a rectangle whose upper left coordinate is r1 and row 1 column 1 and bottom right coordinate is row 2 column 2. So the coordinates is basically a range, right? So if we the upper coordinate is this, let's say for example we want to look at r1 as our rectangle, sub rectangle that we want to update. So the upper coordinate will be this row. Yeah, sorry, this is the top of the rectangle, right? This row here, and the upper coordinates for the columns, right? I've already represented the rows. The columns will be from this point here, right, up to this point, or from this point or to up to this point here, right? That is the upper coordinate of the subrectangle, and the lower coordinates will be the same. It will be this row here. This will be r2, and then the column values will be from here all the way to this point here, or from here all the way here, or the full thing. So we don't know. It's based on the values that we've been given in our update sub rectangle method that we will know. It's based on those values we'll update the rectangle itself, right? So let's take a look at this example. So r1 here is 0, right? So it means the first row, and our first row is here. C1 is 0 as well. So what does 0 mean here, right? 0. Well, we can't say for sure, right, that it is going to be only this row, right? It's going to be only this column here, right? Because we are giving two values, right? So it means R1 is our upper coordinates, right? Upper left coordinates, and then r2 is our lower left coordinates, so that we can actually get the two sides of the rectangle, right? So we have this side and this other side here. So r1 is our upper coordinate, r2 is our upper coordinate, so it's our lower coordinate. So we want from the upper side here all the way to this third row here, right? So let's start from 0. So this will be 0, this will be 1, this will be 2, and then this will be 3, right? In terms of row, we want to update from this first row here all the way to the last row here, right? So that is basically what we are doing for the rows. And for the columns, right, we want to start from 0 all the way to 2, right? So this is column 0, right, all the way. This is column 1 and this is column 2, right? So yeah, so that is the range of meaning we want to update row 0 all the way to row 3, and then we want to update every value, right? Every value from column 0 all the way to column 2. So it will be, this one here will change to with you change to the value here, which is 5. So we'll have something like this. We'll have 5, 5, 5, 5 again, 5, 5, another 5 here, and so on, right? For all the 4 rows and columns. That's all. And this is the Python code for it. Yeah, I created the rectangle property and then use that rectangle to perform all the operation, right? And the get function too is quite simple. So we want to get a particular value from the sub rectangles, and that's it. So let's move on to the next one before they take the light. um, I would like to study about stacks. So what do stacks do, right? What are stacks basically? I read yesterday that stack is a linear data structure that follows a particular order in which are performed. The order may be, so let me mark this, sorry, before I continue. So the order may be uh, the other may be LIFO, which is last in, first out, or FILO, which is first in, last out. LIFO implies that the element that is inserted last comes out first, and FILO implies that the element that is inserted first comes out last. So they both mean the same, right? So this is an illustration of a stack. So we push in A first, right? Before A got to this bottom, it was the first one to be pushed into the stack, and B followed, and C. But to remove A, it will be the last one to be removed, right? So C that came in last will go out first, B will follow, and then A will come last, even though A was the first to be inserted in the stack. All right, so that is what is a stack is. So these are basic operations on a stack. Um, we have a push, which adds an element on top of the stack. Pop removes an element from the stack. Pick returns the first returns the top element without removing it. Is empty checks if the stack is empty. Is full checks if the stack is full, right? And this is basically when the stack is of a fixed size, right? Now a stack is just an array, right? It is just an array. It is just an array. Yeah. So here are some. So let's look at easy problems. But before we get to the easy problems, let's also understand some other stuff. Um, Application of stacks data structure. So we have stacks in recursion. Yes, that is true. Um, Expression, evaluation, and parsing. I don't know what this is. Depth first search. I've not done depth first search. Undo and redo operation. And I actually read this yesterday and I was really excited. So here is what I understood, right? So if undo and redo operations are stack based, um, you know, undo and redo operation use stacks, then when I type something, it means this operation has been added to a stack. When I undo it by pressing Ctrl Z, then it's popped off the stack. I can do Ctrl Y, and then it will, add it back, which means that we have like two stacks here, right? It pushes, when I perform an operation, it pushes that operation onto the I'll say like a doing stack, right? A doing stack or a operation stack. And then when I press Ctrl Z, right, it removes this from the doing stack. I'll just let me illustrate this here. Here's my understanding of stacks, and let's go. So I'll take in the case of undo. Oh God, undo plus redo, right? Undo plus redo. So how if this is a stack and a stack is like this, so we have this somewhere. I'll just represent it by um, this cup here. So we push something on top of the stack, right? And then we remove something from the stack, which is the the most important operations we perform on a stack, right? So here's what's going to happen, right? For undo and redo this undo and redo command, right? I'll say this undo is Control Z, right? Control Z when you're on a Windows computer, and redo is Control Y. I'll just remove this. Control plus Z and Control plus Y, right? So this is undoing and this is redoing. But what are we undoing and redoing? We are undoing an action. So I'll just say action, right? The action could be, typing a word or something. So I'll just put like, hello here, right? Now, when we type something, right, this thing gets added to a stack. So I'll call this action. I'll call this yeah. I'll just put action here. The action gets added to a stack. Or let me just put the string here. I'll say string. Sorry, I typed hello, right? Hello gets added to a stack, right? This stack I'll call it action stack, right? I'll just represent it by AS. So action stack like this, right? So when I type something, it gets added to the stack. Okay. Now I want to undo this action that I just did here. Well, to undo it, then I will have to remove the correct. Okay, let me say I typed a bunch of text, right? I typed hello, I typed word like this. So word will also get added to the stack like this, and then every other value. Now if I want to undo, if I press undo, right, undo will remove the recent item on the stack, or the topmost item on the stack, which was the last one to be added to the stack, but it's now the first one to be removed. So it is performing a LIFO operation. So here's what we are going to do. We'll remove this word here, right? We'll remove it, but where are we putting it? We have to put it where we are going to redo. So I'll create a redo stack, right? So this is redo stack here, redo stack, right? This redo stack would then take the word now, right? The word will now be in the redo stack here. So it will be the first one to be inserted here. And hello, if we are also removing hello from the stack, we need to put it here. We need to put it in the hello here, right? Now our redo stack has the recent items that we've undone. So to do it again, right, to redo this operation, we need to what? We need to push it our main stack, right? So if I typed, let me do it this way. If I typed hello world, right, right. When I press Ctrl Z, okay, this was too it was too slow. Let me just type it quickly. Or let me just type H and E, right? H and E are two words. I typed H first before E, but which one do you think will be removed first? Yes, it's going to be the E, right? E will be removed first because it is the one at the top of the stack right now, right? So when I press Ctrl Z, okay, there was no delay. Let me just type H and wait a bit, and then type E. So if I press Ctrl Z, E will be removed from the stack. If I press Ctrl Z again, H will be removed from the stack. But if I press Ctrl Y, H will come first because H is now the first item on top of the on redo stack, right? H is now at the top of the redo stack, so hello here, right? And then E will come last. So that is an example of a stack. um so let's go ahead and look at some questions that we can find in in stacks. So easy problem. Okay, let's see what this problem asks of us. I'll check. These are a lot of constraints, right? I'll go all the way down and see how long it is. It's very long though. But let's go ahead and read it. Okay. So convert infix expression. What's an infix expression? Let's go and check what an infix expression is. Expression in the form of A operator B, so A plus B, when an operator is between a pair of operands. Okay, right. Write a program to convert an infix operation to a postfix operation. So infix operation is the operation in the form of, okay, A operator B, that is A plus B, when an operator is between a every pair of operands. Okay, postfix operation expression, sorry, the expression in the form of A B operator, so A B plus, right? Okay. um when every pair of operand is followed by an operator, so we have something like this: A plus B star C plus D, and so on, right? So the output should be after every operand. So we want to have A plus B. Now A B before the plus between the two, and then B C before the plus between them. I mean this asterisk here, which is a um a multiplication sign. Then we have this as well. So how do we do something like this? This is an interesting question, and it is supposedly um a basic question in terms of stacks. So how do we solve this? Well, is there an explanation? I don't want to look at the explanation yet, but let me think about it. So I'm giving this as an input, right? Is this going to be like a string input? Obviously it is going to be a string input, so the string is going to be, sorry, the string is going to be A plus B times C plus D, right? It's just, a string, right? So we want to use stacks to convert it to something like this: A B C star plus D plus, right? So how do we do that? Let's think about this a bit. So I'll go to my canvas here, right? I'll remove everything and I'll come here and just create and write a string. I'll just call this str is equal to A plus B, I think star C. What else? A plus this as C, plus D plus D, right? So we want to convert this to something like this. So we want to have the values first. So we want to have A, right? Then followed by B, right? Then followed by the uh the this value here, so it's supposed to be plus, right? But then there is a star between C and B, so we want to have it like this: C plus star, right? Let me look at it again. Yes, C star plus D plus. This is, why is it not? Are you sure this is supposed to be? Because it says the operand has to come after a pair, right? So we have plus here. If we have plus, then C is supposed to be like this: C star, right? Then C star has its own plus, so D plus. I think this is how it's supposed to be. Oh. But then the question says it's like this: A B C star and then plus D plus. What has D done? This is not fair. This is well, why is it like this? Um, I don't understand this, but let's think about this a little. Hypothetically, right? If we were to arrange every alphabet um before a particular operand, right? Every operand has to come after a pair of alphabets. We want to use a stack. Let me just use a basic example, right? I'll just undo all of this, right? And I'll use a basic string A plus B, right? A plus B. So the result of this will be something like this. We'll have A, B plus, right? This is what we would have normally. This is what they call it again. Uh, something. Uh, what's the name? Infix expression to postfix expression. So this is our infix expression. So I'll put it this way. So this is our infix expression, and this is our postfix expression, right? Postfix expression, right? Now, how do we convert this to this place? Obviously, we are going to use stack. We are studying stack, right? So, um, well, to do that, first of all, we know that a stack is what's a stack? A stack is just an array, right? It's not necessarily an array, but like something you can iterate over, right? By inserting and stacking items on top of the other one, right? So we'll have like um let me see. We can have something like this. My god, why am I typing like this? Okay, finally. You know what? This is bad. Let me properly trace this. Okay, not too bad. So we want to stack items here. So we want to stack, let's just say we want to stack it this way. We want to stack A, B, and then plus, right? From this infix string here. How do we do that? How do we stack it this way? Well, if you think of this, right? If we when we iterate over our strings, right? We iterate over our strings, um we can first of all take the string that is not an operand, an operator, sorry, which is this plus here. It could be plus, star, or minus, right? So we can then take that item that doesn't match any of the operators and stack it on top of I'll call this the postfix, right? This is the postfix. So anything that is not an operator, then we'll put it on top of this place, right? We'll insert it in our stack. So this would have been the first item in our stack, but then we want to add another B again. So we'll stack it one after the other. And then how do we stack the operand on top of everything? Given that the operand appeared between two of them, we would ignore if it is not a letter, right, or a number, if it's not alphanumeric. Okay, but then we want to still put the operand at the top of everything after the this thing, or or postfix might not be our stack, right? We can just stack any other thing here. So let's say we stacked we stack A and then B, right, separately, and then once we are done with the items here, then maybe when we got to this place, we stack this on top of some operands stack. I'll just call this operands, right? Operand stack. So when we see A, right, we put it in our I'll call this alpha num stack. Alpha num stack, right? We'll put A here in our stack, but when we see plus, we'll put it uh in the operator stack. I don't know why I'm calling this operand operator stack, and then when we see B, we'll put B on top of the alphabet stack, alphanumeric character stacks, and then at the end of the day, we'll now combine both of them, right? So we'll have alpha alpha num stack, alpha num stack plus operator stack. That is my first solution for a simple example like this one, but there is a catch, right? In this complex one here, I mean a much longer one, if we're stacking everything after I think there's I'm not sure if this is correct, this if this should be the output, but let's read it and see. Why postfix representation of the expression? The compiler scans the expression either from left to right or from right to left. Okay, consider this, right? Now the compiler first scans the first expression to evaluate the operation. Oh, wait. The compiler first scans the expression to evaluate the expression b times c, right? Then scans against then again scans the expression to add it to a to add a to it. Okay, the result is then added to d after another scan. The repeated scanning makes it very inefficient. Infix expressions are easily readable and solvable by humans, whereas the computer cannot differentiate the operators and parentheses easily. So it is better to convert the expression to a postfix or a prefix form before evaluation, right? So here's what we have. The corresponding expression would look something like this. In a postfix form will be ABC star plus D plus. Okay, this is interesting. How to convert infix to a postfix? To convert infix to a postfix expression, use the stack data structure, right? Scan the infix expression from left to right. Whenever we get an operand, we add it to the postfix expression, and if we get an operator or parenthesis, add it to the stack by maintaining their precedence. Oh, wait. Okay, so this says what to convert an infix expression to a postfix expression. Use the stack data structure. Scan the infix expression, right, from left to right. Whenever we get an operand, add it to the postfix expression. And if we get an operator or a parenthesis, add it to the stack by maintaining their precedence. Their precedence or hmm. So here's what the question says, right? Let me let me erase this from here. I'll just remove that, right? So here, okay, let me just do this. Oh, come on. So I'll just use my simple string again so that it's easy for me to understand what I'm doing. So str is equal to a b plus b, right? Now, whenever we see, you know, a character, right, a letter, we want to add it to what? To the, I'll just move this to this side. We want to add it to the postfix expression. At the end of the day, we want our postfix to look like a plus b, a b plus, right? So let's call this postfix. Postfix, right? Now, when we see a character, we want to add it to this postfix expression. So I'll put a here, right? Good. Now, when we see if we get an operator, right, or a parenthesis, add it to the stack by maintaining their precedence. Their precedence. So we want to add it to a stack. So let's say we have a stack here, stack, right? Stack is equal to something like this. So we want to add this operator to the stack, right? We want to add it to this stack here by maintaining their precedence. What does this really mean? So if A was the one preceding, right, preceding this plus here, when we are looking from left to right, then how do we add? So are we doing something like this? Are we doing A plus? Would this be what we add to the stack? Would this be what we add to the stack? A plus. I am not sure, but let me continue reading. I kind of tried to get so scan the infix expression from left to right. So we are going from left, right? This is our left all the way to the right. Okay. Now, if the scanned character is an operand, which is a character, put it in the postfix expression. Otherwise, do the following. If the precedence is an associativity associativity of the scanned operator, if the precedence and the associativity of the scanned operator are greater than the precedence and associativity of the operator in the stack, or the stack is empty, or the stack contains a parenthesis, then push it to the stack. Push it in the stack. So we have, an array of this arrow operator, which is supposedly raises something to a specific power. Operator is right associative, and other operators like plus, minus, and star are left associative. Check, especially for a condition when the operator at the top of the stack and the scanned operator are both this. In this condition, the precedence of the scanned operator is higher due to the right associativity. So it will be pushed into the stack into the operator stack. Is I think we are going to be working with two stacks. I'm not really sure. But let's continue. In all the other cases, when the top of the operator stack is the same as the scanned operator, then pop the operator from the stack because of the left associativity, due to which the scan operator has less precedence. Else pop all operators from the stack which are greater than or equal to the precedence than that of the scanned operator. After doing that, push the scanned operator to the stack. If you encounter parentheses while popping, then stop there and push the scanned operator in the stack. So if scanned character is an opening parenthesis, push it to the stack. If it is a closing parenthesis, pop it from the stack, and the output to the repeat 2 to 5 until the infix expression is scanned. 2 and 5. Okay. Let's see an illustration of this, because I don't really get it, but yeah. So repeat this. Once scanning is over, pop this stack and add the operators in the postface expression until it is not you see. Finally print the postfix expression. Sorry. Follow the below illustration for a better understanding. So consider the infix a plus b star c plus d, right? And the infix expression is scanned using an iterator I, which is initialized as 0, right? The initial value of I will be 0. So we are looping through this string here. The first step, I and expression I here, right? When I is 0, expression I will be A, because A was the first one in the string. An operand, right, is not an operator, so add this to the postfix expression. So we add it to the postfix expression. Okay. Then what do we do next? Second step. The second step here, I is 1, right? And the ith element, or when I is 1, in our infix expression, it is a plus, which is an operator. Push this onto the stack. So we are pushing plus to the stack. Okay. A is equal to, so the postfix A, right, which is preceding this, and the stack is this. Okay. Now I is equal to 2, right? When I is equal to 2, the postfix will still look like this, and we'll add. So we don't add anything here because the stack will still be plus. So next time we look into our infix operator, we see another operator, right? Our infix expression, we see another operator. So we add this operator to the stack operators. Okay. Now this has a higher precedence, so push it into the stack. Push it into the stack. Now we'll have something like this. Oh, I see. Okay. So now when I becomes 4, right, it means we are here. So it's C. So we add C to the postfix, which is ABC. And when we see a star, I mean, this is the fourth step, sorry. When we see a star, we add it on top of the stack because it has a higher precedence over this one here. Okay. Okay. Now I is equal to 4. And the ith expression here is an operand, so we don't add it, so we add it to this place here. Okay, so let's see. So our stack is still looking like this. Now the ith step, now I is now I, right, is a plus, so it's an operator. The topmost element of the stack has a higher precedence, so pop until the stack becomes empty. Oh, I see, has less precedence. So pop until the stack becomes empty or has less precedence, right? So star will be popped and added to the postfix. Okay, okay, and there'll be plus. So this one will be popped. It is going to either be empty or has less precedence. Plus and plus have the same what I say, strength level. So yeah, so these two will be together. Don't worry, I'll explain this all over again. I kind of get it now. So when we pop until the stack is empty, we'll add it to the postfix here, right? Okay, once that is done, right, now the stack is empty, so push plus onto the stack, right? Then when we see another operand, which is D, we add D to postfix. And yeah, so that is the end of the array. Then we just, no element is left, right? So we just add. This makes so much sense. It makes so much sense, and I'm going to try and implement this. But first of all, let's understand the question all over again. It's actually good that I will use this same example here, right? I'll use this same example and explain it again, so I get it now. So here's what we are going to do. First of all, I have a string, right? This string is is an infix string. So I'll say str is equal to a plus b, right? A string that has operands and an operator in between the operands. Okay, now in this case we just have our prefix string, right? Prefix, or yeah, postfix, sorry, postfix string here. Our postfix string will first of all collect every values that are not operators first. So here's what we are going to do when we are looping, right? When we are going through this string, the first character here is a, so we add a to our prefix, string, right? So a prefix will be like this, a. Then the next character is a plus, so we add this to, I'll just put up stack like this, up stack, and this is operator stack, and I'll set it to something like this and push it to the stack, so we'll have plus here. The next operator will be b, right? So we add b to the string here like this, and the last item in this string, b is basically the last item, so we don't have any item to look at. Once we don't have any item to look at, then we just take this value that we added to our stack, even if it is 1 or 2, we take everything and we add it to the prefix, I mean the postfix string, right? That is what this does. Now in a much more, you know, broad uh, infix string. In a much broader infix string, we'll have something like this string, right? I'll just create one out of my head. I'll just say, okay, five. Well, let me just use character A plus B plus C star D minus F, right? And I'll put it this way, okay? And I can just put like another star here. Now, how do we convert this? This is actually interesting. So first of all, we create our postfix string. I'll call this postfix string. Then the postfix string will first of all take the first string that is not an operator. So our operators will be something like this. It will be plus, minus, star, and division. What else? Yeah, for now I'll just do this one for now. I think there are parentheses as well, but let's just start with this. Okay, now star and division, they all have bigger priority over these two, right? And this will come in handy when we are doing the comparison, the insertion. So I'll use another color for that. So first, in the first iteration, we'll use I as our iterator. So I is equal to 0. So I is here, 0, right? When I is equal to 0, the character at this point is a an alpha numeric character, right? So A. So we'll push A into our postfix string. This will be A. Then the next one is an operator. So we put it on the stack. I'll call this up stack. Operator stack is equal to something like this, right? Now let's push this onto the stack. So we'll put our plus here. So it means when I is equal to 1, we want to push that item to the stack. Okay, that's good. And when I is equal to 2, so we have B, so we push B into the postfix operator stack. When I is equal to 3, we have an operator again. No, this is not postfix operator, this is a postfix string, sorry. We have an operator again, so we push that operator onto the stack. We have a plus here. Now, these are two pluses, right? So both of them don't have precedence over the other one. They are all the same. So I'll keep it there like that. And then the next time we see another character, this is C. So we'll put C here, right? But this time around we have a star. So a star has precedence over you know a star has precedence over every other one here, so we want to push a star on top, right? Want to push it on top, so a star is at top. And then we see D again, so we put D here. The next time we see a minus. Now this is where things get interesting. So this minus here does not have any precedent. It's not I would just say it doesn't have a strength over our current operator in the stack, the topmost one. So all we need to do is to push everything that was here, that existed here, onto our postfix string. So we'll start from here. We want to pop, right? When popping item, we pop from the top. We can't start from the front, right? We always start from the front. So we'll have star here, right, before the plus, plus, and then we will now push this minus on top of our stack. So all of these will be cancelled out, right? Then we'll have minus here. Now minus will be our first item in the stack, but last to be removed. Okay, so we have F again, so F will be here, and then we see another star here again. we'll put the star on top because it has a higher precedence over this. And once we don't see any item, once we reach the end of the string, we'll collect everything again and put it here. So we'll put star here and then minus. Right, this is good, this is good. Okay, now when we see a parenthesis, right, like this, or two parentheses, what do we do in that case? Well. Does the parenthesis have precedence over um, other operators? I know this operator is a right associative operator and other operators are left associative. So check if check for a check especially for a condition when the operator at the top post of the stack and the scanned operator are both like this. In this condition, the precedence of the scanned operator is higher due to its right. Okay, so does this mean that plus and minus are going to be higher than this one here? My time has ended. Let me add another 10 minutes grace time for myself. So, okay. It's right associativity, and these are left associativity, associative operator, and this is right. What about parenthesis? If you encounter a parenthesis while popping, okay, so a parenthesis can appear anywhere. Oh, okay. So when we scan a parenthesis, right, we need to push it to the stack. If the character is a closing parenthesis, then we need to pop the stack until we find an opening parenthesis. Okay. So and discard both of them, right? This makes sense. Okay, I think this makes sense. um can we have like, can I edit this? Okay, so let's say our string is, let me use my string that I created. So I have a plus b plus c star d minus f. So I'll just put it here. I'll type it out. Oh, it works. A plus b plus c star d minus f star. Right. So let's see what this gives us. Let's run this. Compiling. Come on. This is actually good though. I can't lie. This is actually good. Where's the error? Oh, sorry. Plus. Plus C star D. Oh my god, what am I doing? Plus C star D. Okay, I know what to do. Plus C star D D minus F star and then this and then yeah. What language is this? This is C++. Interesting. All of this. Oh, okay. So I made a mistake here. So I made a mistake here. Here's what we have. This is supposed to be the solution. I'll bring this back to the screen. Oh, what have they done? Okay. So this is the solution, but here's what I did. Um so when you see operands that are the same, right? I think they should be popped off the stack, right? They should be popped off the stack, and then you continue. So when you see operands that are either the same or have, you know, okay, let me use this as a minus, right? Instead of a plus, let's use a minus and see what happens. Uh, just experimenting and seeing what goes on. Plus, oh my god, I is this how this editor works? Plus minus C. Oh god, help me. Minus C star D minus, okay, D minus F star. Yeah. So what's gonna happen? Oh Christ. Okay, so when operands are exactly the same, right? One has to be ignored. So CD, 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 CD. So if this is the case, then interesting. Then you need to forget about one of them, right? So we have plus. This has to come before it. So this, and that. Wait. I said, what was my string? Yeah. So when operands are the same, you pop it off the stack. So let's do it again. I will do it this way. So here's what we'll have. Let me look at my string again. So we'll have A first in the postfix, then B. I'm looking at this string here. So we'll have A first, then our stack is here, so we'll put plus in it, then B, right? But then the next one we see here is also a plus. So we'll empty the stack, plus, and then add, because plus is the same, so this is the current one. I'll just put plus like this. So because plus is the same as this one that is already in the stack, so we just empty the stack and add it here. So we'll look at the next item, right? The next item would be a C, so we'll put C here, and then the next one is a star, right? A star has to be, you know, the biggest one, so we just put our star here. This replaces our star. Then we go ahead and add D to the prefix, right? But then we see, we see a minus now. What do we do with the minus, right? I'm coming. Let me use the toilet. Oh. Okay, I'm back. Um, so when we see a minus, right, we can add. Uh, so we can we have the minus here, right, which is this one here. What am I saying? Let me go back and look at this very well. You know what? Let me copy this string, right? I'll delete everything. Let me just put this here. This is our string. I'll just use this one for my example so I understand this better. There's just a confusion about, which operand is higher than the other. So this will be our result. Let me increase this. Okay. So we have the prefix stack, the postfix. So I'll put, oh my god. No, no, no. I wasn't going to type. Remove this from the stack. So we have our postfix stack here. So when we see a character here, this is A, right? So we put A here. Now this is a plus, right? So we take this plus here and add it to the stack. So we have plus in our stack currently. Okay. Um the next item we'll have is B. So we put B in the postfix here. But the next one we see here is a plus. Is a minus, right? So what do we do when it comes to a minus? Right. Well, we remove everything that was there before and then add the minus to the stack now. So X will be removed. I'll just cancel it like this. S will be removed. Now minus is on top of our stack, right? So when S is removed, it is appended to B, AB, sorry, and then minus is the current element that we have in our stack. So we'll see the next item will be what? Will be C, right? So we have C here, and then the next one will be star. So we can star can stay on top of um you know of plus, minus, yeah, plus and minus. So we can pull star on top, right? So star will go on top of this one here like this. Now the next item will be what? Will be D. The next item is a minus, but minus can't stay on top of a star, so we have to push clear the stack again. So we'll clear it by doing this. So we pop the first item onto from the stack and put it into the postfix. So we have a star here like this, and then minus will follow it, right? So we have a minus like that, and then this stack will become clean now. So oh, I have an eraser here, I've completely forgot. So our stack will become empty again. Once again, let me just delete that and put it here. So the next item we have in our string is f. F is a non alphanumeric character, so we just put f there. And then the next item we have, so the minus was already on the stack after we cleared the stack, so minus is there. So we see another star, we put the star on top, but this time around we don't have any item to look at again, so the string is closed. And once we reach the end of the string, we want to add every item that was on the stack to the string. I see, I get it now. You know what, let me give myself another example. So let's say um I had I'll use a white color for this. I'll say our infix string is equal to a plus b star c star d star f minus e plus plus e again, right? Let's just put plus a. Now how do we do this? Well, the first thing to do is to just loop through each character and add it to the postfix when it's an operand, or the my time is up, or the the operators stack if it is an operator. So we take the first one here, so we'll add the postfix here. I'll just put a string here like this. I'll start the string like this, so a, right? Let me use a different color. So this will be our string. We'll have a here like this. What kind of thing is this? So we'll have a like this. A is our first character in the string. Then I'll just represent this with the stack, operator stack, up stack like this. So I'll just create a big cup here. So the next item we see is this one here, so I'll put the plus here. The next one will be a b, so a b is alphanumeric, so we'll put it in the postfix. And the next one is a star, right? This star here has a higher precedence over our former one here, so we want to add it to the stack, so we'll add a star to the stack like this. The next character we see is a C, so we put a C here like this. And the next one will be this operator here. This operator here. But we can't add the operator on top of the previous ones because the topmost one is the same as this one. So we need to clear the stack. So we'll clear the stack like this by adding the first one on top of the stack, which is the star, and then the plus here, right? So now the stack will be empty. Let me remove this here. The stack will be empty. Then we can now add this to the stack, right? Oh my god, we can now add this to the stack, so we'll have our star here. Then we'll continue looking through the string. The next item is a D. Now the next item again after this D is a star. We can't put a star on top of a D, so we'll put the star in our postfix string, and then keep this one here. I'll just assume this is the star that we replaced with the former one, so this will still stay in the string. We'll put F here, right? We're at F, And then we have minus. Minus can stay on top of the asterisk or multiplication sign, so we need to empty the stack once more. So we'll push everything on top of this, so we'll have, you know, the asterisk in front of f before leaving this minus at, now this minus will be at the top of the stack. So then we put our e, right, e, and then we see a plus. A plus and a minus are basically, you know, have the same levels, so the one can stay on top of the other. So we clear the stack again once, but we have minus here, and then we put plus on top of our stack. Then we have a, we put a here, and then once we reach the end of this string, we just add every item that was in the stack, which is just this plus here. We have the plus here. So let's test this out and see if it actually works. And you know, if it does, then congratulations, we have, I don't know why this is doing that, so I'll just go with this. So I'll say a plus b star c star d star f star, right, how many stars do we have? 3 stars plus, okay, f minus e plus a, right? So let's run this and see what it does. So, oh, it did not add this, so this was, oh my god, what have I done? Okay, this will first of all throw an error. Oh, damn. So we have to tap. Okay, okay, we are back. All right, we know there is an error. So let's see. Now this should be correct, and just see the value. Um, this is taking long to compile. I don't know. Just give me the answer already. Yeah. So moment of truth. Um, sorry, let me bring this back here. I don't know why did I add this plus here. Okay, it would have been the plus from, then maybe I didn't type everything correctly. Did I not? My answer is incorrect. So A, B, let me just do it this way. We have A, B, C, A plus B, star C, star D, star F. Why did they add star? Where is this plus for AB? Where is it? I think this is just like some technical issue. Normally this should have been the answer. This should have been the answer. All right, that's studying data structures, stack data structures. Tomorrow we'll continue solving. I will continue solving problems. This is just trying out stacks for the first time. Let me look at the Python code for this. I don't know why I didn't click on Python all this while. So, right. Wow. Well, let's first of all look. So they're creating a precedence function, right? This precedence function takes, so this is 3. If C is equal to this or that, it's just 2, and every other value is 1. Makes sense. Otherwise, it is negative 1 when it's parenthesis. Now, associativity. Okay. If C is equal to, this arrow, then we are returning R or L. L is the default one. Okay, so we have results, which is also a stack, like I said, and this stack is also an operator stack. So C is equal to Si, the correct item in the array. So if A is less or equal to C, right? Or if it is a character, well, this could have just checked if it is alpha num, right? But this is also another way to do things. I think is alpha num is just doing something like this under the hood, maybe with extra checks. Well, this makes sense. Then the result is just a string. Here we are removing every item from the stack when we find, a matching, a closing parenthesis, which means that we've already added a an opening parenthesis, right? And if the value of this one is less than stack pre-stack minus 1, so this is the topmost stack, and this is any the correct S, right? Okay, if this has precedence over the other one, or they are the same, and their associativity is L. So if we are looking at any operands that is not an arrow, right, which is what this is, we want to clear the stack. Okay, this is actually good. um I'll come back to it again after this stream and study it properly and understand the different stacks here. I would, do this infix convection, all of this, right? Medium problem as well, unless it is not just stack but other data structures, then I will just not waste my time on it. But yeah, we have the prefix to infix conversion as well, so like vice versa, we are going back and forth. This will be good after studying with this one. Yeah, so I'll come here tomorrow to continue the problems. Ciao.